না একটু দিয়ে জানা রে। আসছি। আজকে হবে না, আজকে হবে না, ছেড়ে দে। আজকে হবে না, স্টার্ট হয়ে গেছে, স্টার্ট হয়ে গেছে, স্টার্ট হয়ে গেছে। লেকচার স্টার্ট হয়ে গেছে, এখন হবে না, হবে না। দিয়ে যাবো কি? না না না, প্লাস্টিক দিয়ে যাচ্ছি, খেয়ে নিই। ঠিক আছে। হুম। আচ্ছা, এক্ষুনি জয়েন করেন প্লিজ। Yes, Ria has joined in. Karishma has joined in. Am I audible to both of you? Just say yes. Am I audible to both of you? Okay, I'm waiting for the others to join. Please join fast. Others, please join fast. Till now, only three of you have joined. The others, please join fast. I'll have to end this class before 4:30. Okay, let us begin. I think people will join late, so let us begin. Let us not waste time. Today we will start with that topic which we could not finish yesterday because of audio problem. That is factor analysis. Factor analysis is a tool of multivariate analysis mainly used for exploratory study. As you have known in your marketing classes, marketing research classes, there are three levels of study: exploratory, descriptive, and causal. Discriminant and multiple regression analysis were used for causal research, whereas factor analysis is used for exploratory research. Research where you are exploring new markets, you're exploring new things, you're exploring new ideas. That is the motive of factor analysis. And now I'll give you a very simple example to start with. Suppose there are plenty of hotels, there are plenty of restaurants across the city. Plenty of restaurants across the city. And wherever you stay, nearby there may be plenty of restaurants. But you specifically like one of them. If you want to go to a restaurant, you specifically like one of them. Why? The moment I ask this question, why, there can be several list of answers that will come in. Several list of answers. It can be because of the ambience of the restaurant. It can be because of the service of the restaurant. It can be because of the service duration of the restaurant, how fast the service is given, how cordial the restaurant staffs are, what is the quality of the food, what is the cost. There can be n number of reasons why you choose a particular restaurant. Similarly, another example. There are plenty of flights available. There can be Indigo, there can be Jet, there can be anything. But while you're traveling, why do you prefer one flight over the others? Again, there can be plenty of reasons. One can be because of the cost, one can be because of the timing, one can be because of your office prefers that, or office gives you booking in that flight. One can be because of the flight air hostess, one can be because of the food, anything, n number of reasons. Now, when you are exploring these reasons, you are doing an exploratory study. And one of the mechanism of exploratory study is factor analysis. Is this clear? Okay. Now, what does factor analysis do? I hope the sheet that I sent you is with you right now. The sheet that I sent you is with you right now. In that sheet, it is written, I just read out. If there are too many variables to work with, please listen carefully, and you also read yourself along with me. If there are too many variables to work with, this tool helps us to reduce the number of variables, dimensions, to a manageable level. You have got X dimension and Y dimension. If you say X, Y, Z, you have got X dimension, Y dimension, Z dimension. So this is 3D. Now, if you go for higher dimensions, higher variables means higher dimensions. It cannot be pictorially represented, but it can be conceptually represented. Now, if you have too many variables, it is written here, the tool helps us to reduce the number of variables or dimensions to a manageable limit. If you have too many such variables, say for example, why you are interested in one particular flight, there are so many reasons, hundreds of reasons that you can find out. That becomes unmanageable to handle. That becomes unmanageable to carry out further research. So to bring that down to a manageable limit, factor analysis is done. Okay? It does so by combining or grouping variables and calling each group components or factors. What does factor analysis do? It combines the variables. If there are 100 variables, maybe variable number 14, variable number 34, variable number 86, variable number 92, variable number 99, variable number 100. All these variables are combined together as one component or one factor. We are calling it component here because factor analysis has got several methods, but the most commonly used method is principal component analysis method. Principal component analysis method, PCA. This is the method that we normally use to conduct exploratory factor analysis. So that is why we call these as components. The combination of variables, we call them as components or factors. Okay, then the combination is done either through correlation matrix or through covariance matrix. Now, the correlation amongst the variables can be an idea or can be a benchmark to combine the variables, or correlation amongst the or covariance amongst the variables can be a benchmark to combine the variables. Normally, we conduct factor analysis through correlation matrix. We take into consideration correlation because covariance is included in correlation. If you remember the formula of correlation before, it was covariance of xy divided by sigma x into sigma y. There is standard deviation of x and a standard deviation of y. So covariance is inbuilt into correlation. So normally we do factor analysis using correlation. The variables which are having more correlations, higher correlations, those variables are combined together. Very, very simple. Have you all understood? Yes, no. Even if one of you say no, I will just explain it once more. Yes, no. Ushi is saying, please repeat, sir. Okay, I will repeat it once more. Okay, Ankit is also saying once more. Ria is also saying once more. Okay, I'll repeat once more. Don't respond now. Listen, very carefully listen. There are hundreds of variables. It is unmanageable. You have to reduce the number of variables. How do you do that? Through correlation matrix. You see which variables are correlated together amongst themselves. High correlations. Say variable number 2, variable number 8, variable number 14, variable number 19, variable number 56, variable number 66. These variables are internally correlated very highly. So what we do is we combine these variables and call these components. The whole combination is called one component or one factor. Why do we call it component? Because the method that we normally use is principal component analysis in doing factor analysis. Okay, this is the method of doing factor analysis. And why do we do factor analysis? For dimension reduction. We need to reduce the number of dimensions, the number of variables we are using with. Because unless until we do that, it becomes unmanageable. It goes on very high. The number of variables becomes very high. We need to bring it down in size. Now is it clear? Yes, no. Until this much is clear, I cannot progress. Ankit, is it clear? Ushi is saying yes. Ankit, is it clear? Okay. Now I can progress. Stop the chat now. Listen to this. While you're conducting SPSS analysis, factor analysis is done through software. It cannot be done manually. Plain and simple language, it cannot be done manually. Through software, how do you do factor analysis? Okay, please stop responding. Listen. Now listen. Whenever I'll ask you to respond, please respond. Now listen. In SPSS, factor analysis is done by going to the menu bar, choose Analyze. In Analyze, you will get a drop-down box. In that drop-down box, you will have something called dimension reduction. It is written in the sheet that I sent you. There will be something called dimension reduction. If you click on the dimension reduction, you will get something called factor. So choose that factor. After choosing that factor, you will get all those variables on the left-hand side. You choose all the variables and shift them to the right-hand side. Then run factor. This is the step of factor analysis. You can test it at home. Now, next concept of factor analysis is rotation. After the factor analysis is done, we normally look at one matrix which is called rotated component matrix. We look at rotated component matrix. The rotated component matrix looks like this. Looks like this. I have given you this sheet. At the end of the sheet, it looks like this. These 1, 2, 3, 4, these are components, means these are factors. These are my variables. Variable 1, variable 2, variable 3, up to variable 100 maybe, 200 maybe, 300 maybe. There is no end to it. There can be as many number of variables as you want. These are inside, the values inside are factor loadings. So, if you have a factor loading of a high value is normally considered to be 0.6 and above. 0.6 and above is a high value. If under a component, try to understand, a variable's factor loading is above 0.6, that variable becomes a part of that factor. I repeat, suppose component number 1, you have got variable 1 to 100. Say variable number 2's loading is 0.75. Variable number 16's loading is 0.86. So variable number 2 will be a member of the first component. Variable number 16 will be a member of the first component or first factor. But some other variables, maybe variable number 22 has got a loading of 0.22. That we will not consider to be a member of that factor. So whichever variables has got higher loadings, they are combined to make one factor. While doing so, it is quite possible that some of the variables are totally excluded. They are not included in any of the factors. It is quite possible. Okay, but after you have done that, it is entirely your judgment. Entirely your judgment, because statistics gives you a guidance. It does not give you a decision. It gives you a guidance. Decision is yours. If you feel that yes, this variable should come into this factor, even if the loading is low, you should bring in giving proper reasons. If you feel that this variable should not be in this factor, even if the loading is high, you may remove the variable giving proper reasons. So these are entirely judgmental. The factor analysis is just giving you an idea of which variables can combine to form the factors. Is it clear till now? Till now, I want 2 or 3 yes sirs. Now I'll explain what is rotation. Rotated component matrix I have explained. Now I'll explain what is rotation. Till now, is it clear? Okay, thank you. Let it be there. No more responses. No more responses. Now understand what is rotation. A very, very important thing about factor analysis is rotation. There are two types of rotation. One is orthogonal rotation. Yes, Shoham Sen is saying till rotated component matrix is clear. Okay, I am only asking till rotated component matrix is clear or not. I have explained till rotated component matrix. I have not got explanations. So till rotated component matrix is clear or not? It is yes, it is clear. Now, what is this rotation? This we need to understand. Rotation means, first and foremost, try and understand one thing. All of you know about cricket match? Cricket match. Now suppose this is a field. It is a rectangle, but I'll manage. I'll manage. It's a rectangle, but a cricket field is a circular field. Here is the pitch. Here is the wicket keeper. Here is the slip. Here is the third man. Understood? Wicket keeper, slip, third man. Now, for a person who is batting here, we'll see the slip and the third man side by side. Because as per his vision, this is a slip, this is a third man. So they are about just next to each other. But for an audience who is sitting here, will see a huge gap between the slip and the third man. A huge gap between slip and the third man. Did you understand? So where you are positioned depends on whether you will find 2 points close or far. Where you are positioned. If you are positioned here, slip and third man will look side by side. If you are positioned here, they will look at an enormous gap. If you are positioned here, there will be a gap. If you are positioned here, they will be side by side. So, if I really want to understand that which point is close enough to which point, I need to rotate the matrix once, twice, thrice, 4 times, 5 times, 6 times, as many times as I want, as I need to. Now see, for a three-dimensional picture only, rotation becomes important. But when we are talking about hundreds of dimensions, imagine how important can be the rotation. A small rotation, a small slight rotation can change the entire purview of the points which are there in the plot, in that hyperplane. A slight rotation, initially 2 points might seem very close, but a slight rotation might, that is rotation by 90 degree, one is oblique rotation. Check this point. Here you will see this is a coordinate axis. This is a coordinate axis. There are some scattered points here, which more or less seems not correlated. But if I rotate this matrix like this, where the angle between the dimensions are still 90 degree, the angles between the dimensions are still 90 degree, it is orthogonal rotation, then you will find the same points, you will find some are close to this dimension, some are close to this dimension. Very clearly you understand. Some are close to this dimension, some are close to this dimension. But this was not so in this case. The same thing has been done. The matrix has been just tilted, and we get to see these points around this dimension and these points around this dimension. This is orthogonal rotation. This is orthogonal rotation. Okay, now oblique rotation. See, the points are scattered here. The points are totally scattered here. We cannot say there is any correlation here. But if we rotate in any other degree, not 90 degree, not 90 degree, then we can see these are the points, these are the points. These are the points which are close to this dimension. And these are the points which are close to this dimension. The points are same as this. Whatever points, places are there are same as places are there. What we have done is we have just tilted the axis. We have just tilted this. This axis became this. This axis became this. So we get to see that points are close to one dimension and the other dimension. This is oblique rotation. So rotation helps in understanding that whether apparently the points are may not be correlated, but if we rotate, if it seems to be correlated, then we consider those correlations. Otherwise we don't consider those correlations. Okay, if you go through this page once more now after this session is over, if you go through this page once more, it will be very, very clear to you. It will be absolutely clear to you what is factor analysis. Fair enough, class? Is it okay? But I would request you to please go through this sheet. Go through this sheet. Okay? Decision theory. All right? Thank you, class.